everyone. So it's Coach Fred. I just wanted to get video number 3 on here for systems of equations. So this is systems of equations part 3. And I'm calling it BAM. I really do understand systems. Okay, so we've been talking a lot about linear systems of equations. Here's an example of something that's not just two lines intersecting. So we have in the xy plane, just means on the coordinate plane, the parabola, that's telling me something, with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points, A and B. What is the length of AB? All right, well, you do need to know the word intersect. That intersect is going to tell me that I'm looking for the points in common for these two equations. Now, if you don't recognize this as a parabola, then I highly suggest you go back to the quadratics video. And if you don't recognize this as a very special line, I really suggest you go back and look at the horizontal and vertical line video. But so we have a parabola, maybe something like this. I actually know it's been shifted to the right 11 units. It's something like this. And I have a line, y equals 25. That is a horizontal line. Just remind you of hoivux. It's a y equals, so it's a horizontal line, something like this at 25. And what this question is asking me for is, it says that it intersects at these points, A and B. You can clearly see in my picture, those are the points. And it wants the length between them. Now, the good news is, the y doesn't really matter. I just need the x coordinates where they intersect, because if I get that x right there and that x right there, then I just need to find the distance between them. All right, so how are we going to do that? Well, a system of equations that's nonlinear, usually the best way to solve it is by using substitution, meaning substitute one value into the other equation. So if it says y equals 25 and y equals x minus 11 squared, I can substitute 25 in for y. Now, this is a binomial squared equaling a number, so this would be a great place to use the square root method. I'm going to take the square root of both sides. Now, a couple places you could make a mistake here. That's going to give me x minus 11 on this side. But remember, when you take the square root of both sides, you have to consider that there's both a positive and a negative 5. So if you forget that, you are probably going to get the answer wrong. All right, so I'm going to rewrite this using the symmetric property. And I'm going to write two separate equations. So I have x minus 11 equals 5 and x minus 11 equals negative 5. So that gives me, if I add 11 on both sides, I get x equals 16. And if you hadn't done the plus minus, I'm going to guess that you probably would have picked 16 as your answer, which it's not. And you're going to add 11 on both sides, and you're going to get x equals 6. So think back to that picture I drew you. Let me do it again. Something like that. Oops, I don't want it to cross the y-axis here. It was something like that. And I was only looking, this was A and this was B. So we have now our A was an x of 6, so 625. And our B is 1625. And I just need the distance between those two, which would be 16 minus 6, which is 10. Now that's a challenging problem. You have to put a lot together, and it took a little bit of time. So you have to get used to the idea of looking for the word intersection, thinking about what you know about a parabola, being able to identify a horizontal line, and then use the geometry of this to see what they're really asking for. That's what makes this test a little bit more challenging, but it's not anything you can't do. I know you can do it. All right, let's look at another unfamiliar. Here we go. It says, which of the following could be the x-coordinate of a solution to the systems of equations? Okay, so this time they told me. They didn't say intersect. They said, which could be the x-coordinate of the system. So that means I want to find x. So I have two equations. They're non-linear. So use substitution. Substitute 2x minus 3 in for y. All right, so that's going to give me x plus 2 squared plus negative 2x plus 4 minus 3 squared equals 40. All right, so now the algebra we have to be careful with. Look at these funky answers. They all look not so great, right? But we got to solve for x, so we got to do some work here. First, I'm going to simplify this expression in here. So that gives me x plus 2 squared plus negative 2x plus 1 squared equals 40. All right, so now you got to use what you know about squaring a binomial. Remember, you cannot distribute that 2 through. Remember, x plus 2 squared means x plus 2 times x plus 2. If you've watched my video on perfect square trinomials, I've shown you a quick way to multiply those. And you'll get, if you multiply them out, x squared plus 4x plus 4. Plus, now we got to do this one. So that process, I'm going to go through it here. You square the first term, which is going to give me 4x squared. You double the product of the inside numbers. So 1 times negative 2x is negative 2x. I double that. That's going to give me negative 4x. And then I square the last term. All right, so now I have a more involved algebraic equation. So what do? We combine the like terms. So I'm going to combine x squared and 4x squared. That gives me 5x squared. The 4x and the 4x are going to simplify, cancel out. And then plus 4 and 1 gives me 5 equals 50. Oh, wow, look at that. Nice. I can subtract 5. Might already start to see some things happening here. So 5x squared equals 45. And did I do something? Oh, I wrote 50 and it was 40. I'm sorry. So I made a little error right there. So let's go back and fix that. And that's going to give me, so 40 minus 5 gives me 35. Sorry about that little error there. And then I divide by 5. And so I get x squared equals 7. And I take the square root of both sides, and I get x equals plus or minus root 7. Don't forget that plus minus. Now I go back, so it says, which of the following could be the x coordinate? Because it could be either positive root 7 or negative root 7, so you can see that your answer is A. All right, hopefully you found that systems video helpful, and have a great day.